Okay, we're now going into section, I don't know why I keep saying 10. 11.7, more about graphing quadratic functions. In this one, we're going to take a look at the form in which we write quadratic functions that will look more familiar to you, but we're going to be rewriting it into the form that we were looking at in section 11.6. So we want to take a quadratic function that looks like this, and we want to rewrite it into the form of like f of x equals a times x minus h squared plus k. So this work is going to involve some of the work that we did in completing the square, but the techniques of this are going to be a little different, and it's going to be a little strange. So I'm hoping to show maybe 5 or 6 examples of this. And then the last couple problems, I'm actually going to show the work from beginning to end, where you actually not only have to rewrite it in this form, but then you have to make the graph, identify the axis of symmetry, find the vertex as the maximum and minimum value, identify the range, everything. So you see how all of this is connected. So, but at the beginning here, we're going to simply focus on how we rewrite these. So this involves some steps. The first step we're going to do in this function is we're going to go ahead and partition the ax squared and the bx term off. So we're going to write this as such. So I'm going to write x squared minus 6x, and we're going to separate this from the minus 1. That's going to be the first part here. The next thing I'm going to do is I need to see if I can factor out an a. A is only 1, so I'm not going to do that. The next couple problems I'm going to do will involve that skill, so you kind of see how that works, but at least I'm going to allude to it at this time. So this is step A. We have to separate the ax squared plus bx term from the c term. B is we would need to factor out a, so like if this, since this is 1, I don't have to do that. But if it were not 1, I would have to factor this out from the a and the b term. And sometimes that can get pretty ugly. So at that point, we're going to be okay. Step C is I need to take half of this and square it. And watch how I'm going to add it. This is going to be a little different now. So I'm going to take 6, and I'm going to divide that by 2. That's going to equal 3. Now when I take 3 squared, though, okay, I'm going to do that here also, and that's going to equal 9. What I'm going to do, because I don't want to change the value of this, is I'm going to write this as x squared minus 6x. I'm going to write this as plus 9 minus 9, then minus 1. So essentially by writing plus 9 and minus 9, I'm not changing the value because 9 minus 9 is 0. But watch how I'm going to partition this off next. This is really important. So I'm going to take this value of x squared minus 6x plus 9, but I'm going to bring the negative 9 on the outside now. So I'm going to bring this negative 9 out here. And what I'm going to do is I'm going to go ahead and put this negative 9 with this negative 1 to get negative 10. What I'm left with on the inside now, x squared minus 6x plus 9, is a perfect square trinomial, which I can now express as x squared minus, or actually plus, no, actually I take that back. I should have put a negative 6 here, gotten negative 3, and then squared negative 3. So this is going to be x squared, not plus 3, but x squared minus 3. And I can write that as, let me start this one more time, guys. I can write x squared minus 6x plus 9 as x minus 3 times x minus 3. And then this is going to be, not equal negative 10, just minus 10. So I can take x minus 3 times x minus 3 minus 10, and I can write this part as x minus 3 squared minus 10. So now what I have is an equation rewritten into the original form that we talked about, where a is equal to 1, h is equal to 3, and then k is equal to negative 10. So this, we went from here all the way to here. Let's see if we can do a couple more of these. We'll try to pick some simple ones that aren't too bad, but we are going to have to pick ones that have values of a greater than 1. Let's go ahead and take a look now at question 14. And as we do more of these, this is going to become clear, but sometimes the mathematics can get tricky. So this isn't real difficult, but it can get tricky. So 14, we have f of x is equal to 2x squared minus 20x minus 3. So again, in my first step here, I'm going to go ahead and I'm going to separate out, I'm going to put a y here, and I'm going to separate out the 2x squared minus 20x from my c term. That's the first step. Next, I see that my value of a on ax squared is greater than 1. So I have to factor a out from this. So that's going to give me y is equal to 2 times x squared minus 10x minus 3. Now, once I do this, I can now take the value of b on the inside, which is negative 10. I didn't miss the negative this time. Divide that by 2 to get negative 5. Star this. And then negative 5 squared is equal to 25. So on the inside of this here, I'm going to write this as y equals 2 times x squared minus 10x plus 25 minus 25 minus 3. Now, this next part gets a little tricky. Here's where you have to be careful. Okay? So this part's going to be a little hard for some people to see. Last time we brought out this minus 25 to combine it with the c value here. However, everything on the inside is subject to being multiplied by 2. So we're going to have 2 times the quantity of x squared minus 10x plus 25. I want to move this negative 25 out. But when I bring it outside, I have to take 2 times negative 25. So when I bring this 25 out, 2 times negative 25 is going to come out as negative 50 minus 3. So you see we're going to have a pretty big number there. Okay, so at this point now, let's take a look at x squared minus 10x plus 25. This can be written as x minus 5 times x minus 5. So I can write this now as 2 times x minus 5 squared. And this is going to combine to be negative 53. So when I have it written in this form, I now have taken this equation, written in standard form, and then written it into this new form here that we learned about in section 10.6 or 11.6. Let's take a look at another problem involving this. Let's take a look now at 16, and let's see what we can do with that. So in question 16, here we have f of x equals negative 2x squared minus 8x plus 4. So again, I'm going to go ahead and replace this with y, and then I'm going to separate out the ax squared plus b term from my c. I recognize here that I have a negative 2 for my a coefficient, so I need to factor out the 2 and the negative. So one thing you need to be careful of when you're doing this, as you factor out the negative, you have to switch the sign of everything on the inside. So if these are both negative, they're going to both become positive. And then this is going to become plus 4x plus 4. And that's going to really simplify this problem a great deal. Not only having the negative out, but having this be a 4. So I'm going to take the b term now, take 4 divided by 2 to get to 2 squared will equal 4. So I'm going to add and subtract 4 on the inside of this. So I get y is equal to negative 2 times x squared plus 4x. And it's going to be plus 4 minus 4 equals 4. Now, again, I need to take this minus 4 off and bring it here. But because I have a negative 2, it's going to be negative 2 times negative 4. It's going to make it plus 8. So when I separate this out, it's going to be negative 2 times x squared plus 4x plus 4. I'm going to leave that on the inside, but what I'm kicking out, I have to multiply by negative 2. So negative 2 times negative 4 is going to come out as plus 8. And then, and this, by the way, this should not be a equals 4. It should be plus 4. So now what I can do is I'm going to write this as y equals negative 2 times, well, x squared plus 4x plus 4. that's x plus 2 squared, then a plus 4, that's equal to plus 12. And we are done. So let's take a look at another such problem. We looked at one with a 2, we looked at one with a negative 2, but we need to look at one with a number when this isn't going to come out so nicely, where the computations can get pretty bad. So we're going to go ahead and take a look at a few of those questions, and let's see what that does. So let's take a look at 18. 18 is a pretty nice example of this, actually. Not nice in the way that you're going to like, but nice to illustrate the complications that can arise from such a problem. So we have here f of x in question 18 equals 3x squared plus 7x minus 3. So we're going to separate out the ax squared plus bx term. Now we have to factor a 3 out, but 3 doesn't factor from this so easily. So the best we can do when we have a 7 is just take 7 and divide it by 3. Like 3 divided by 3 is 1. But 7 divided by 3 is just going to be 7/3. So it's going to leave us with x squared plus 7 over 3x minus 3. So when we're forced to work with these fractions, yes, it's going to result in some unpleasant calculations that a lot of you are not going to like. But let's go ahead and do that now. We have the value of b as being equal to 7/3. And just like we did when we worked at completing the square in section 11.1, we can divide by 2 or just multiply by 1/2. And that's going to give us 7 over 6. If I take 7 over 6 and we square it, that's going to give us 49 over 36. So we need to add and subtract that inside. So that's now going to give us f of x, or let's just go ahead and put y in that place now. 3 times x squared plus 7 over 3x plus 49 over 36 minus 49 over 36 minus 3. Now, before we hit the panic button yet, I'm going to introduce an intermediate step here because of the complications of the fractions. So one thing we can do, we can still write this out. So we have x squared plus 7/3 x plus 49 over 36. But when I bring 49 over 36, especially minus 49 over 36 on the outside, I can go ahead and bring this out. Well, I know 3 times negative 49 over 36, that's going to be minus. So I'm going to bring this out as 49 over 36 times 3 over 1, because that's the 3 here. And then that's going to be minus 3. So instead of actually doing the calculation, here and then bringing it out, I'm going to just rewrite this calculation on the outside here and then work that out. So one thing I can do here next is I can rewrite this as how? Well, from my intermediate step here for 7 over 6, which we usually star, I can go ahead and write this as x plus 7 over 6, that quantity squared. But we still need to work these details out. So first off, we have 3 on top, we have 36 on the bottom, so that's going to give us minus 49 over 12 minus 3. So we have 2 negative quantities. We need to resolve the fractions of this. Probably the easiest thing to do is to go ahead and write this original 3 here from the beginning of the problem. We're going to go ahead and write that as negative 3 over 1. And let's go ahead and multiply the top and bottom by 12. So this is going to give us here negative 49 over 12 minus 36 over 12. That's going to produce for us negative 49 minus 36 is going to be negative 85 over 12. And you can leave that as just negative 85 over 12. You don't have to rewrite that as anything else. So we can write y equals 3 times x plus 7/6 squared minus 85 over 12. Oh, in case you're wondering what the graph of, or what the vertex of that would be, okay, the vertex, let me put this up here, the vertex of this is going to be negative 7 over 6 and negative 85 over 12. Now, I don't think it would be reasonable to ask people to try to put pen to paper on that. That would be a pretty awful one to graph. So they haven't asked you to do that for these particular questions in this case. Usually the ones that they're going to ask you to graph are going to be simpler, but there may be some where you're just asked to write this in the form where you can easily extract the vertex and the axis of symmetry, so on and so forth. But the big focus of the lessons here is simply rewriting it from the standard form you're comfortable with into the form of a times x minus hi quantity squared plus k form. So let's take a look at working out a few of these problems and then obtain the information that we need from these. Okay, so look at working some more of these where we first have to work them out, and then we'll work to get everything beginning to end. So let's see here. Let's go ahead and take a look at. We'll start by taking a look at 26. So I'm going to start with one with a negative. So 26, let me make sure it's showing up on the screen here. Okay. 26 is going to be f of x equals negative x squared plus 2x plus 5. So we're going to rewrite this first, then we're going to, given this information, identify the vertex, identify the axis of symmetry, identify if it's a maximum and minimum value, and then we're actually also supposed to graph the function. So I'm going to do this with just a couple of these, and that is going to wrap up our lesson for this section, at least for the first half of the section. So for this part here, we're going to separate this out like we've done before. I have a negative here. I need to factor that out. That's going to switch the sign of everything on the inside. Now I have a negative 2 for here, so I'm going to take negative 2 out. Divide that by 2. It would be negative 1. Make sure to star this because we're going to use this later. So this is going to be negative, the quantity of x squared minus 2x plus 1 minus 1. And I'll go ahead and make this y now. You can make this y earlier if you want. I just didn't do that at that time. So when I bring this out, it's going to be negative 1 times a negative. So it's just going to be, I bring it out as plus 1 plus 5. And now I'm going to go ahead and rewrite this as, let's see, x minus 1 squared, and this will be plus 6. So there is my final answer to this. So let's just identify a few things. From this, going forward, we can find everything else we need except for the graph, which I am going to wait on the graphing for the next problem where I have the graph paper up front. So for this one, we can identify the vertex, or actually let's just identify A, H, and K. A is going to be negative 1, H is going to be 1, K is going to be 6. So given these values, we know that this is, since A is negative 1, this is going to be a parabola that's going to be shaped something like this, like a frown. So it's going to have a maximum value. But we know that the vertex is going to be 1 and 6. We know that the axis of symmetry, I'm just abbreviating here, that's going to be x is equal to 1. I get that from the x value of the vertex. Because we know that A is equal to negative 1, this is going to be a maximum. So it's going to be a max. And it's going to be max of the y value of the vertex at 6 for the range. Since this is going to be a max, it's going to go from negative infinity to 6. And the rules for graphing this should be the same. I'm going to pick one more problem to go over in this section before going to the last part and going from there. So let's take a look at one problem that we're going to work through completely and then graph. So it'll be just one more problem in this section. Let's make sure you can see everything. So we'll kind of move here first, and then we'll go to the graphing portion. So let's go ahead and take a look now at, it's going to be 32. And I think for the ones that they have you graph, I think they try to make these not uber difficult to do this procedure with. So it's going to be f of x equals negative 3 x squared plus 6x plus 2. Let's go ahead and put the y out now. This would be negative 3x squared plus 6x plus 2. I'm going to factor out a negative 3. So this is going to be negative 3 times x squared minus 2x plus 2. I'm going to here I switch the signs of everything because I factored a negative out. So I'm going to take negative 2 divided by 2. You get negative 1. Star that. Negative 1 squared will be 1. So I'm going to add 1, subtract 1 on the inside. So y will equal negative 3 times x squared minus 2x plus 1 minus 1 plus 2. When I bring the negative 1 out, I'm going to multiply it by negative 3. So negative 3 times negative 1 will be 3. I'm going to bring that as positive 3. And now I can rewrite this, add this, and that'll be y is equal to negative 3 times x squared, or excuse me, not x squared, but x minus 1 squared plus 5. So what do I know based on all this work so far? Let me make sure that everyone can see that solution. Good. I'm going to know that, and I'll try to save the room up here for the table. I'm going to know that my vertex is going to be 1, 5. I know that my axis of symmetry is going to be from here. I know it's going to be x is equal to 1. Because the value of y, or the value of a, is going to be negative 3, I can determine that it's going to be a graph that's shaped like this, so it's going to be a maximum at negative 3, and that the range is going to be from negative infinity up to negative 3, because it goes all the way down to negative infinity, tops off at negative 3. So let's go ahead, and we're going to put that point down on the top now, and we're going to look to see how we make a table for this. So we have the values, 1, 5, so let's put that up here. How do we pick the values for this? Well, negative 3. We mentioned before that when this number is big, it's going to make the graph more narrow. Having a value of 3, negative or positive, may actually cause this to be somewhat difficult to graph on the space we have. So I'm going to kind of do my graphing here. So x, y, then we have, let's see, 3 times x minus 1 squared plus 5. So what I'm going to do is I'm not going to fill all this in. You should know how to do this already from the previous lesson. I just want to generate the x values so you're comfortable with that. So I know that my x value is 1 here, so I'm going to go 0, negative 1, and this will be 2 and 3. So I'm just going to generate my y values here. So for 1, I know that's going to be 5 here, and I'm going to expect these to be less because this is a negative 3. So for 0, negative 1 was so 0 minus 1 squared is minus 1, negative 1 squared is 1, minus 3 is 3, so that's going to be 2. This should be 2 also. Check the work. Negative 1 minus 1 is negative 2, negative 2 squared is 4, negative 4, or excuse me, 4 times negative 3 is negative 12. Negative 12 plus 5 should be negative 7. This should also be negative 7 again. Feel free to check the work. And when we plot these points down, you'll notice that the graph of this parabola, since the a is equal to 3, as I mentioned, as the value of a gets bigger as it's greater than 1, the parabola that is graphed produces a much narrower graph. And then finally, let's go ahead and graph the axis of symmetry through here, where x is equal to 1, and that shows to be true. It does in fact show a max at, not negative 3. So the max is not negative 3. I'm not quite sure where I got this from. The max comes from the y value here. It's going to be 5. Okay, and that's why it's good to do this sometimes. And then this is going to be negative 5, or not 5, negative 5, but positive 5. That's why it's good to sometimes do the graph of this here. So given this, you should have enough to do the questions in this lesson here. There are a few questions at the very end here that I will address in a small but separate video. They're not real hard, but if you hold off on answering those questions, that'll be fine. They're like maybe the last 3 to 5 questions in your lesson. You can hold off on those until I return from my trip. Have a good day. Oh, and just one more thing. I'm just noticing here that when I wrote down the max and the range and I corrected this, this was not captured in the video. So when I talk about changing the max and relating that to the vertex, here's what I did and here's how it impacted the range. So just making sure that I capture that for the video. Please let me know if you have any questions and submit your comments to this video with those, and I'll be glad to kind of chime in and answer those as needed.